So for the two-way chi-square analysis, again, we are comparing observed frequencies to expected frequencies. The difference where this two-way kind of comes in is that we are doing this across two separate variables. So this may look slightly familiar to some things that we did in Chapter 2. So in Chapter 2, we looked at frequency tables split across two dimensions or two variables. And so what we would actually be testing here is the null hypothesis that our two variables are independent or not related. And our research hypothesis would be that our two variables are related or they're dependent. So in order to test our null hypothesis, again, we have to compute a chi-square statistic, a chi-square value. So just like we did in the one-way chi-square analysis, we're going to start out by determining what is our expected frequency. So the calculation for expected frequency is a little more complex because, again, we have two separate variables. So I have a hypothetical data set here. You see that one variable is the participant's gender. So remember from the last video that in this hypothetical study, we have a group of participants who watch the political debate, and then afterwards we ask them, who do you plan to vote for? So let's say that we wanted to split our data set by gender to examine whether or not males or females have different voting patterns or expected voting patterns. And so I have females and males in my sample, and I'm also looking at the candidates. Again, who do they indicate that they're going to vote for? So this time, just to simplify it a bit, I have just two candidates, so Biden and Warren. And if you remember from the last video, we said that 40 participants indicated that they would vote for Biden and 60 participants indicated that they would vote for Warren. So we're just looking at that subset in this analysis, those people who said that either that they were going to vote for Biden or that they were going to vote for Warren. And so we have 60 plus 40 gives us a total sample size for this analysis of 100. And so I could look to see, well, out of these people who say that they're voting for Biden or Warren, is there a difference in gender for selection? Maybe I might hypothesize that females are more likely to vote for a female candidate, whereas males are more likely to vote for a male candidate. Right? So the gender of the participant is related to the candidate chosen. There's some type of dependent relationship between these two variables. And so in order to test that hypothesis, I need to first determine what are my expected frequencies. And so to determine my expected frequencies, I'm going to look at the row total and the column total. So here I want to know how many females should I expect if gender is unrelated to candidate selection. How many females should I expect to vote for Biden? What should be the expected frequency for this cell here? I would take my row total of 50. So there are 50 females total. There were, here if I look at my column total, there were 40 people overall who indicated that they would vote for Biden. And we have a total N of 100. So I would take 50 multiplied by 40 and divided by 100. And so my expected frequency here is 20. So I'm just going to put that in parentheses. Now let's determine my expected frequency for Warren. Again, I would take 50 as my row total. This time I would multiply it by 60, which is my column total. So 60 people overall indicated that they would vote for Warren. And again, I would divide that by 100. So 50 multiplied by 60 divided by 100 gives us an expected frequency of 30. For this cell, I would look at my row total of 50 multiplied by 40 divided by 100. 50 by 40 divided by 100. I should expect 20, just as we got here. And again, 50 multiplied by 60 divided by 100. And again, I should expect a frequency of 30 here. So these are my expected frequency if my null hypothesis is retained. So if gender is unrelated to presidential candidate chosen. So now to calculate my chi-square value, we have, in general, the same equation that we had for the one-way chi-square analysis. So we have our observed frequency minus our expected frequency. We square that, and we divide by the expected frequency. So in each cell, I would take my observed frequency here, 10, subtract 20. I would square that, and then I would divide by my expected frequency of 20. So the expected frequency for each cell. So here I would take 10 minus 20, square that, and divide by 20. And so I do that for each of these cells. So for each one of these cells, I've taken the observed frequency. I'm subtracting the expected frequencies to get a deviation score. I'm squaring that deviation score, and then we're dividing by the expected frequencies in each cell. And so that would give me 4 values if we calculated that out. So let's take 10 minus 20 squared divided by 20. So for our first cell, we get a score of 5. 40 minus 30 squared divided by 30. We get a value of 3.33. If we take 30 minus 20 squared divided by 20, we get again a value of 5. And finally, if we take 20, subtract 30, square that, and divided by 30, again we get 3.33. And so what I would want to do is to sum all of these values. So I should get a sum of 16.66. So this would be my chi-square value, 16.66. Again, I need to compare this calculated chi-square value to the critical value in my table. So we would use that alpha or significance level of 0.05 that we've been using. We also need to determine our degrees of freedom. So this is a little more complex again because we have 2 separate variables. And so with the one-way chi-square, we calculated our degrees of freedom by the number of categories minus 1. So we need to do that same thing, except for this time for each variable. And so K1 is for our variable 1. We could take that to mean our gender. So there are 2 categories minus 1 would be 1. So this would equal 1 times. For our second variable, again, we have 2 categories. 2 minus 1 is 1. So 1 times 1, of course, would be 1. So we have 1 degree of freedom. So let's take a look at our chi-square table. So for our chi-square table, we said that we wanted to use the significance level of 0.05, and then we have 1 degree of freedom. And so our critical or tabled value would be this right here of 3.84. So we'd compare that to our calculated value of 16.66, which exceeds the critical value of 3.84. And so we would reject our null hypothesis that states that there's no relationship between our two variables, and instead support a research hypothesis that there is a relationship between participant gender and candidate chosen.